In this section, we're going to go over the concept of rate of change. So we're going to differentiate between average rate of change and instantaneous rate of change. But before we do that, I would like to explain what we mean by rate of change. So in a graph like this, we have the x and y lines. X is going to represent our independent variable, which means it is a variable that does not depend on any other variables. And then y is going to represent our dependent variable, which is the opposite of independent variable. It means that dependent variable, it does depend on a variable and it's going to change according to that. So rate of change is basically when there's a change in the independent variable. We're interested in finding how rapidly our dependent variable changes. So if we look at the graph, when I change my x, so let's say that this is my x, so from this point I change my x to this point. I see that my y also changes accordingly. So in this point I had y, let's say this is 2. So I had y as 2 at the point 1. And then my x, and then my x independent, I changed it. So as soon as I change it to 2, my y also varies according to the changes that I made in the independent. So it changed to, let's say this point is 4. Now onto the average rate of change and instantaneous rate of change. I'm just going to separate and differentiate between what those are. So average rate of change, we're already familiar with it. The slope of secant, and it is between 2 points. So just like we did, we found out the formula for slope of secant to be fx2 minus fx1 over x2 minus x1. We are already familiar with these. So instantaneous rate of change, this is what we did in the section 1.2 with limits. We said it's the slope of a tangent and it passes through 1 point. And we found that in order to find slope of tangent, we used the limits. Since we're already familiar with solving average rate of change and instantaneous rate of change by finding the slope of the tangent line, I'm going to go ahead and solve questions that are specific to this section instead. So we're going to see a lot of word problems instead of problems that we solved in previous videos. So I'm going to start out by solving more of the basic questions. This is going to be focused on more word problems because this section is more of the section that we already did, but integrated into word problems. So first 4 is going to be rather easy. So if you're already comfortable with integrating limits, instantaneous rate of change, you can skip. But these are the basic ones that's going to come up either on the test or you're going to see it basically. So the first thing is the total cost of manufacturing X calculators is given by the function Cx equals 5 root x plus 2000. First portion asks us what is the total cost of manufacturing 25 calculators. So, and then the second portion is what is the rate of change in the total cost with respect to the number of calculators X being produced when X equals 25. It says we have X calculators, so X represents number of calculators. And if I look at the function, C is going to represent my total cost because the whole function in the first word, it says the total cost of manufacturing X calculators. So C is total cost. It's better to say Cx because it represents the whole y. So you can say like y equals total cost, but we're saying Cx. For manufacturing 25 calculators, so I know I have 25 calculators. That's my number of calculators. So that's going to be my X. And it asks me to find the total cost. So this is what I'm trying to find. So when I put X into my original equation, I get 5 root 25 plus 2000. So if I solve that, root 25 comes out as 5. So I have 5 times 5 plus 2000. And that's going to equal 5 times 5, 25. And then plus 2000 is 2025. So the total cost for manufacturing 25 calculators came up to be $2,025. The second portion is saying, what is the rate of change? So as soon as I see rate of change, I know it's either instantaneous or average rate of change. So I need to figure out which one it's asking for. And then it continues by saying, being produced when x equals 25. It gives us 1 point only. So I know since it doesn't have 2 points or a range, I know it's instantaneous rate of change. How do we calculate that? Is by using limits that we used before. So I already put up the formula. All I need to do is plug in 25 for x into the formula. So when I do that, I get limit as h approaches 0 is f25 plus h minus f25. So when I integrate 25 plus h into the original equation, I get 5 root 25 plus h, and then plus 2,000, and then minus f25 is basically what we found in the first portion of the question. We integrated 25 as x into the original equation and ended up with 2,025. So I'm going to go ahead and put that, and then over h. And do not forget, we put limit as h approaches to 0 every single time we write it. So from here, I realized that I can write these, like add them together and end up with minus 25. And I also realized that I cannot get rid of 25 plus h anymore. So I'm going to use its conjugate and get rid of the numerator. So basically rationalize it. When I use its conjugate, I'm going to end up with 5 root 25 plus h. And since my sign is negative over here, I ended up with negative. I'm going to change it to positive 25. Same thing for the numerator. Now I'm going to go ahead and multiply these two together. When I do that, I end up with 25, and then root times the same thing is just going to come out of the root. So I have 25 plus h. When I multiply this by plus 25, and the next thing I'm going to do is multiplying negative 25 with the same thing, it's just going to cancel out, so I don't bother writing it. And the last thing I'm going to multiply is minus 25 with plus 25, which is going to come up to negative 625. So now I'm going to multiply h by whatever it is, but I'm going to write it as in the brackets. So I have 5 root 25 plus h, and then plus 25. Now I'm going to go ahead and simplify it further. So I have limit as h approaches 0. 25 times 25 is 625, and 25 times h is going to be 25h. And then I have minus 625 over h, and the same thing over there. I see that I can cancel out positive 625 and negative 625. And I also see I can cancel out h's over here, and I already got rid of it. Now I ended up with 25 on top over 5 root 25 plus h, and then plus 25. Now all I need to do is plug in, because I don't have any h's, that's gonna make my solution undefined. I'm gonna start by putting h as 0 over here. So when I do that, I ended up with 25 over 5 root 25, because it's plus h, and then when I do plus 0, it's still there, it doesn't cancel out, and then I have plus 25. Now I can say 25 over root 25 comes out of 5, and then 5 times 5 is 25, so 25 plus 25 is going to give me 50. When I simplify these by dividing both sides by 25, so divide 50 by 25, I get 2. Divide 25 by 25, I'm going to get 1. So my answer is 1 over 2. And I can also say that it's $0.50 since it's in cost. So my rate of change for per calculator is $0.50. Second problem is velocity of an object is given by vt equals t minus 2 squared. At what times in seconds is the object at rest? So it's saying at what time is my object not moving, or the velocity is basically 0. So the first thing I'm going to do is, because this represents velocity and I found out that my velocity is 0, I'm going to put 0 for that and then write my equation as this. Now I'm trying to find what t is. It says at what times is the object at rest. So I said it's at rest, and whenever I find the t over here, I'm going to find my answer. So I'm going to divide both sides by t, and I ended up with 0 equals t minus 2 squared because these canceled out. And if I expand this, I'm going to end up with t squared and then minus 2t, add them up, minus 4t, and then minus 2 times minus 2 is going to give me plus 4. Now I'm going to end up with t minus 2 and then t minus 2, which is going to be the same thing, equaling to 0. So when I put this out, saying t minus 2 equals 0, and then put 2 onto the other side, I have 2 equals 2 seconds. So this is one of my answers. So if I look at the graph, and let's say this is my vt and this is my t, so time versus velocity, and let's say here is my 2 second, right? So it needs to start from somewhere, and let's say velocity comes back to 0 at 2 seconds, because that's what you found. I also say at t equals 0, because that's the starting point, the velocity will also be 0. So I ended up with answers t equals 0 and 2 seconds. So both can be our answers. It will specify in terms of accepting 0 seconds or not. It will differ, but in this question, it accepts it as 0 seconds also. So in this question, it's more of a case where medicine is administered to a patient. The amount of medicine M in milligrams in 1 milliliter of the patient's blood, t hours after the injection is mt equals -1/2 t squared plus t, where my t is between 0 and 2 hours. So first portion is asking us, find the rate of change in amount M 2 hours after the injection. So just to see what it's asking for, so I have a medicine and I have a patient, and we're injecting that medicine into the patient's blood. So t represents my hours, which I can think of x if it makes it easier for you. M is going to represent the milligrams of the medicine, how many milligrams are in the patient's blood. So first portion is saying rate of change. As soon as I read rate of change, I can say, okay, instantaneous or average rate of change. I need to figure out which one it wants. And then it says 2 hours after the injection. So since my x or t is hours and it's saying 2 hours after the injection, I can immediately say this is basically saying t equals 2. And since it's like that, I can say, okay, I'm going to use instantaneous rate of change. So I start by writing my formula for finding the instantaneous rate of change. And I'm going to go ahead and use, instead of x, I'm going to replace it with t. So I know my t is going to be 2. So I'm going to go ahead and write 2 plus h, and then minus f2 over h. And I'm going to plug in 2 plus h into the original equation. Same thing with 2. So limit as h approaches 0, and then I have -1/2, 2 plus h squared plus 2 plus h minus. As soon as I plug in 2, just to make it easier, I'm going to do it in here in a box. So I'm going to plug in -1/2, 2 squared plus 2. So from here, I know 2 squared is 4. 4 times -1/2 is going to equal -2, and then plus 2 is going to equal 0. Even now, I know I don't need to even put anything, so I'm just going to erase this over h. From here, I'm going to expand 2 plus h, so I have -1/2, 4, so 2 times 2 is 4, 2 times h, and then I have another 2 times h, which is, when I add it up, it's going to come up to plus 4h, and then h times h is h squared, and then plus 2 plus h over h. I'm going to simplify it even further. -1/2 times 4 is going to equal -2. -1/2 times, here I did this, and then I'm doing this right now. So -1/2 times 4h is going to equal -2h. -1/2 times h squared is going to equal -1/2 h squared. And then I have plus 2 plus h over h. I see that I have -2 and I have plus 2 over here canceled out. Now I have all h's left, so I'm going to start by taking the h out. So as soon as I take the h out, from -2, I have -2 left. -1/2 h squared, I took 1h out, and then plus h at the end is just going to come out as 1, and then over h. So I cancel out these h's. Now I am left with -2, -1/2h plus 1. Now I can say, okay, now plug in 0 for h. So this is canceled out. I'm left with -2 plus 1, which comes out to -1. And since I found what m is, so my m is going to be milligrams per hour. So since I found the rate of change being -1 milligram per hour, so what it means is after 2 hours, so let's say I have 3 hours, so going from 2 to 3, my milligrams goes by like -1. So let's say in the patient's blood I had 5 milligrams, and then that's for t equals 1. For t equals 2, I'm going to have -1. So since I had 5 milligrams, it's going to go down to 4 milligrams. 1 hour passes by again, it's going to go down to 3 milligrams. 1 hour passes by again, 2, and then goes on and goes on. So the second portion is asking for what is the significance of the fact that your answer is negative. So it's negative because it represents medicine being dissipated all over the body. In the logical sense, it has to be negative. Other than that, if it's not negative, it basically means the drug didn't leave patient's blood. And it's even increasing, which is not really possible, but if there's a typo on your test and it's plus, don't blame me. It's just solve it as it is, and you can just blame it on your teacher that it was positive, but it needs to be negative in these cases. So question 4, I'll be solving the portion A because we didn't solve any of the average rate of change questions, but portion B is basically the same thing that we did for the last questions. It's finding the rate of change, but I'll start with the whole question and then you guys will see what I mean. So it asks us to suppose that a student has learned nt in a function nt equals 10t minus t squared vocabulary after t hours of uninterrupted study, where t is between 0 and 5. So how many terms are learned between the time t equals 2 and t equals 4? So since it's asking for how many terms, and my terms are represented by nt, because t is equal to time, so t is my time, then nt is my vocabulary, which is terms. So it's giving me 2 t's. So from average and instantaneous, when I compare instantaneous, I only had 1 point. So in this case, whenever I have 2 points, we said we are using the slope of secant, we're using average rate of change. So that's what we're going to do for the portion A. So in this case, my formula is going to be f t2, which I can say t2 being 4, and then I'm going to say t equals 2 being t1, and I'm just going to put those numbers into my original equation like we did before. So when I put t2, which is 4, into my original equation, I'm going to get in brackets 10, and then for t I have to put 4, so I'm putting 4. And I have a minus t squared, so I'm going to go ahead and say minus, my t is 4 again, and then squared. This is my first portion. Second portion is putting t equals 2 into the original equation. So I'm going to do the same thing, 10. Instead of putting 4, I'm putting 2, and then minus 2 squared over my t2 is 4, and then my t1 is 2. So I'm going to say minus 2. From here, I'm going to go ahead and simplify. 10 times 4 is 40, and then 4 squared is going to be 16, so minus 16. Minus 10 times 2 is 20, and then 2 squared. Be careful with this one because I'm multiplying negative by this, so that's why I have a negative 20, and I'm also multiplying negative by this negative, so I have positive now, so it's positive 4, and over 4 minus 2 is just going to be 2. So when I do, I'm going to start with this. So 40 minus 20, I'm going to get 20. So 20 minus 16 is going to give me 4. And 4 plus 4 is going to give me 8 over 2. 8 over 2 is just going to be equal 4. So I can say she learned basically 4 terms, because that's what we found for. So it's asking for how many terms she learned, 4 terms between the times 2 and 4. So for B, it's asking for what is the rate in terms of per hour, and then it's saying at which the student is learning at time t equals 3h. So when I look at this, yes, it's asking for a rate of change. So when I'm comparing to instantaneous and average, I have only 1 point, so it's instantaneous off the bat. So I can say use the equation of limit as we did, and all you're going to do in this question is plug in 3 hours into the x, which is going to be t. So we did that before, so I'm not gonna bother solving it. So for this, you should end up with 4 terms again.